much, Dimitris. And good afternoon, everyone. I'm Meng from UCLLED, and I will present our work titled HVAC-informed thermal zoning for BIM2BEM, translation, transformation, yes. And before that, I would like please allow me to use 1 minute to acknowledge the grant that to support our research. This is a European Horizon project. It was running 3 years and just wrapping up this month. Next, I will talk about the methodology. And then the first one is, let's say, use case or motivation. You know, in the DigiBuild project, there's several, nearly 9 or 10 pilot. And all of them, most of them require repeat execution for building energy performance simulation. You know, that is BIM, building energy modeling, and to support the decision making. And the BIM data of several of them feature very complex building geometry and diverse functional spaces and requiring the model simplification. And there's another motivation from us is we want to propose a seamless and automated BIM2BEM framework that integrate the HVAC information and trying to improve the zoning accuracy and the simulation reliability. Okay, that's about motivation, and the next is methodology. The methodology can be divided into 3 stages. The first one, stage A, is focused on the geometry data processing. The second stage is the zoning scenario generation, and the third stage is model simplification and enrichment. Let's go to the first one. The first one, stage A, is the geometric data processing, and generally, in short, is from the IFC to XML, and then go to the GPSML, and the last, the aim is the IDF for energy plot simulation. I will go deep in the next. And the stage B is the zoning scenario generation. It can be further divided into 2 parts. The first part is the HVAC topology establishment. It's based on the semantic technology, it's knowledge graph. And the second is generate the set of zoning scenario to map the IFC spaces in BIM to thermal zone for BIM. And the last stages is model simplification can be divided into the first part is the model simplification. There's 2 I will mention it further. And then the second part is how to populate the HVAC information from the knowledge graph, HVAC topology into the IDF, energy plus model. Okay, the next slide shows the stage 1, geometry-related BIM2BEM transformation. And you know, our work is not from scratch. And in this work, we integrated several tools we developed over the past several years. For example, you can see the first one. This tool name is the Geometry Exporter tool. The aim is to extract the data, geometric data, 3D boundary representations for the building spaces, and the opening from the IFC file, and then into the XML file. And the stage, the A2, you can see that based on this, the BIM geometry generation has been obtained, and that is a secondary level space boundary. It's a surface set via CIB. There's another tool we published several years before, and via this, we can use these methods to define the thermal interface between the space, and as well as the space and the environment. And the last is the BIM geometry exportation to GBML, and via this tool, we can export the external secondary level space boundary mapped into the GBML with another tool, ETL tool, is developed several years before, and while the internal surface pairs are merged into the single surface. The workflow you can see is like this, from A to B to C. This. And beyond the geometry, let's go to the HVAC part. It's the zoning, thermal zoning. And the first part is HVAC topology establishment from the BIM. And this work was presented by my colleague Georgios last year in Kahania, EC3 meetings. In short, how to do that? We use the knowledge graph technology And there's another tool we developed, the GRC, Geometric Relation Checker, to enforce the connectivity between each HVAC component. And via this work, we can get a representation, digital representation of the relationship between the HVAC components aimed to mirror the real-world HVAC system. And the second part is the zoning rules and the scenario generation. And the zoning scenario are generated to map multiple IFC into the thermal zone. Maybe one thermal zone, maybe two thermal zone, maybe several thermal zones. That depends on if they are adjacent or functionally similar, and they have to be served by the same air handling unit, AHU. Yeah, they have to be served by the same ventilation system. Yeah, there's another citation, you can find more details. And the last stage is the model simplification and enrichment. And there's another tool that we developed a couple years before. Its name is the simplification tool, and to simplify the secondary level space boundary surface and merge the adjacent IFC spaces into thermal zones. Yes, it can be guided by the string generated from the HVAC topology. And another novel polygon simplification methods we propose. The aim is to reduce the number of the boundary point along curves, the polygon edge, make the triangulation easier for simulation engine. Yes, in Energy Plus, there are some limitation of the number of the vertex for each edge. And the another part is the model enrichment for generating the simulation-ready BIM. Only the geometry is not enough for run a reliable simulation. We need to enrich it with the HVAC information and internal heat gas, and also the control logic, something like this. All of this information has been stored in the HVAC topology knowledge graph, and via the semantic technologies, all of this information can be populated into the geometry BIM IDF format. As you can see, this is a workflow to show how we integrate all the tools and the methods into together, and we want to try to make the BIM2BEM the workflow as robust, as seamless, as automatic as we can. So this is all of the methodology, and let me go to the application example. There's a case study in UCL East Campus. This is very, very new, just was opened 2 years before. This building name is Wemple Street. You can see that this is a large volume, it's very new, very complex buildings. We focus on the podium part, because the podium part is stored advanced HVAC system for cooling, heating, ventilation, and also some heat recovery unit is very complicated. And for the tower part, it's only for the student living accommodation. There's no any ventilation system, only the radiator in the tower part and some heat recovery. In this case, we only focus on the podium. And for the podium, there's a total of 166 spaces. And unfortunately, we don't have the opening information, window for the row beam. So we cannot test this functionality, but it's fun. We can also test the workflow we proposed. And for the beam, for the HVAC, as you can see, it's very detailed. It's very nice. It includes the air loop and also the water loop for all of the components, the 3D geometry representation, and how to generate the zoning scenario based on the HVAC topology look like this. And we identify 7 mergeable groups to map the multiple IFC spaces to thermal zones. As I said, maybe to 1 thermal zone, to 3 thermal zone, to several. That depends on whether they are following our rules. And there's a total of 128 zoning scenarios are generated separately, considering the first constraints. It's an interflow, which means that the modeling can happen across the floor, in different floor. And the second, the intra-floor constraints mean that the modeling can only happen within each floor. That's a different. And the next, let me show some result. Effectiveness of the BIM2BEM workflow. Please go to the figure A. As you can see, some of the internal wall has been removed successfully. You can see that in the bottom figure. And in the interflow zoning scenario, not only the internal wall, and also the floor slab has been removed successfully. So you can see the internal wall and the floor slab. And beyond that, let's go to the figure B, so visualization of the baseline, full model. And it's just used to highlight the polygon simplification for some angles. Yes, it's just for reduce the flexibility of the building's geometry. And the last figure C shows the visualization of the baseline. As you can see, there's a window. How we do that? Yes, we use another way to set up the window based on the window to wall ratios, which is from the building manual, decision drawing. If we can got raw BIM data have such information, we can definitely test our workflow, how its performance for dealing with the window openings. And the next is some quantitative result of the simulation in terms of the heating and the cooling energy demand. As you can see, the thermal zone, the number of the thermal zone is reduced from 166 to under 113 by merging all the mergeable groups. As you know, the AHU is not serving all the building. It's only cover nearly half of the spaces. That's why the result is like this. Let's go to the cooling and heating demand. As you can see, the difference, the drop is not a lot. It's only 10%, less than 10%, 7 or 9 with the interflow zoning. But if we go to the intraflow zoning, which means that the zoning is only happening within the floor, the difference is very, very little, only 2 and 3% compared to the baseline. Okay, and let me go to the conclusion and the future work. Conclusion, the first one is that we propose HVAC-informed thermal zoning approach, and that can enhance the BIM2BEM workflow and then enhance the seamless data interoperability across IFC and the GB-XML and the IDF. And the second one is by using the knowledge graph-based HVAC topology, it can accurately mapping between the BIM physical IFC spaces and the BIM thermal zones, and then supporting the flexibility of the building simulation. And the third one is our workflow was validated on a very complex building, Wampo Street. It is very complex, not only the building geometry, but also the HVAC system. And there's some result. As you can see, the difference is not quite a lot. And we want to highlight that the critical role of the HVAC integration in improving the BIM2BEM accuracy and reliability and flexibility. It's very important to take the HVAC information into account when you want to do some thermal zone for building simulation. And is there some limitation? Yes, this work requires a BIM data of a certain quality. As you can see, we do have the whole building's BIM data. It should be higher than LOD 300. It's very good, something like this. And we can allow that. We can accept that the data is not perfect, it's imperfect, but it would be good to collect all the information. And the future work is definitely we will extend our workflow from the podium to the tower part. Whole building and also the openings, and extend to the whole building and test. And then maybe we can also incorporate some additional factors. In this case, we're only taking into account the energy demand. Maybe the thermal comfort and the IAQ, another indicator, can also be taken into account. Okay, thank you very much for your attention, and thank you very much for the contribution from our team.